So, today I studied algebra, and I'm just going to recap what I learned today. So I've been through stuff about logic, symbolic logic, which is all about how to do some proofs. Turns out that's not the whole story, because there are some proofs that are you just have to prove a statement. If you just have a single assertion, then there's no, as far as I can tell, right now, there is no symbolic logic argument to set up for that. So I don't know how to come up with those, because they seem fairly obscure, but right now I'm reading about the integers, counting integers, positive integers, and prime numbers, which turns out to be a really important part of it, I guess. So one thing that I went over today was two numbers are said to be, so a prime number is a number that is only divided by itself, and 1, except 1 is not considered a prime number itself, I think, which is a little confusing, because it seems like it should be. But, so that's a prime number. There's another label that people have come up with for when you have two numbers that don't divide into each other. One of them can't divide into the other one, and I think they don't both have to be prime numbers. You can have a non-prime number and another non-prime number, as long as one can't divide into the other one. I'll have to check up on that, but there's such a thing as called coprime, and that's called coprime. But the important thing is that the coprime numbers are determined by, there's an equation that you can use to determine if two numbers are coprime, which is 1 equals coprime number 1 times some other integer plus coprime number 2 times a different integer. And if that equation is satisfied, if two coprime numbers multiplied by two separate numbers added together equals 1, if that's true, then you have two coprime numbers. And that can be used to prove that if you have a prime number that divides into a product of some other integers, 2 or 3 or 4, if you have a prime number that divides into those, then the prime number divides into at least one of those one of the factors making up that divided number. So if a prime number divides A times B, if that's true, then the prime number also will divide into A or B, or both. And then there's another skip to a really important, apparently, theorem in algebra, which is that any integer can be expressed as a multiplication of a bunch of prime numbers. So you can always get from prime numbers to any other number, any other integer, which is pretty cool. And it was proved now with symbolic logic, but with some minimal element in a set type of argument, which I've seen before, but I wouldn't think to use that at first. So that's called like the fundamental theorem of algebra, and I'll have to look at that more because it seems pretty cool. So that's where I stopped off for today. I think I studied for about an hour after reading a bunch of Richard theme stuff, which was really cool. So I feel comfortable with the math stuff now. It's taken me about a week to work up the guts to actually sit down and look at it and feel good about doing it. So hopefully more of that in the future. And I'll pick up with the making any integer with the product of prime numbers the next time. So maybe I'll do another one of these. Okay, see you later.